this is R. Gayatri, Associate Professor, Department of Pharmaceutics, SNS College of Pharmacy and Health Sciences. So today we talk about the topic is ideal solubility parameters. This is the continuation of the solubility of the drugs. So what is ideal solubility parameters? It is the numerical value that indicates the relative solvency behavior of a specific solvent. So this is the process of the solvation. Sometimes it is called as a solutions. Okay. So the amount of the solute is dissolved in the solvent is called as a solution. They have two types of the solubility parameters. One is Hildebrand solubility parameters and Hansen solubility parameters. It is based on this energy that is called as a cohesive energy. The cohesive energy is defined as the potential energy of the liquid. It is divided by the volume. It is divided by the volume of the solvent. From the heat of the vaporization, it is following this RT, and this is called as cohesive energy. So cohesive energy is nothing but it depends on the solvent and solubility interactions between the parameters. And what is Hildebrand solubility parameters? This is the formula for the Hildebrand formula. So del 1 is equal to delta U by V. So here the delta H, there is the heat transfer. It's based on the temperature and the volume of the solvent in the half. So this is the formula for the Hildebrand is delta H equal to RT by V in the half. Okay, so here the solution theory, it's a regular solution theory. It is characterized the non-polar solvents in terms of the solubility parameters. In the del 1 is solubility parameters, and the formula for this is delta T equal to delta D plus delta P plus delta H. So then Hansen solubility parameters. So Hansen solubility parameters is developed by the scientist Hansen. So in 1967 was predicting the one material will dissolve in the another form of the solution. So they are based on the idea that dissolve like dissolve. So where one molecule is defined as a like, it is dissolved completely in the solution. If the one solvent is unlike, they do not dissolve in the solvent. So the Hansen predicted the solution undissolved like a dissolved solution. If suppose the solute is dissolved in any kind of the solution, the polarity is very, very important. The polarity nature, it's depend on the molecules or ions are present in the component. So especially each molecule is given in the parameters. So generally the MPa is a 0.5. So that is the unit of this solutes. And this Hansen solubility parameters, it depends on this formula. So here the del D is the energy of the dispersion force, and the delta P is a dipolar interactions, and the del H is based on the hydrogen bond between the drugs. So in that Hansen is derived if any of the component is following the solubility parameters, it depends on the dipole moment and polarity of the nature and the heat radiations of the energy. So these are the very important solubility parameters for if you are selecting in the any kind of the solute or the solvents. The three parameters is treated as a coordinator for the point at which the three dimension is known as a Hansen space. So the Hansen space, they have two molecules in the three-dimensional. So they have the dissolved like in the each other. Solvation means they are intermolecular charges are combined together. They form a homogeneous measure. And associations means the solute molecules having the oppositely charged particles, they are combined together. They form aggregates is called an association. In that association, they have three distinction features. One is fully soluble and freely soluble and not soluble. So if we are making in the A component and the B component, they are combined together, they form a AB complex. So that is called as a solvation. If the A molecule, oppositely charged molecules, they attack in the B molecules means they form a equivalently they are miscible to each other. And the A molecules is completely repulsive the B molecules means they are not dissolved. So the association components are not suitable for preparing any kind of the formulations. If the solvation components are very suitable for the preparation of the formulations. Thank you.